Almost all of our space exploration relies on what we, or our telescopes, can see. Now and then, scientists also lick a moon rock, touch a meteorite, or simulate the sounds of stars. But even those aren't the only senses we can use to learn about space. We can also study its smells. Now, no one's ever been anywhere other than the moon to take a sniff, but scientists think we have a pretty good idea of what some places smell like anyway, which is neat, because the process of decoding astronomical aromas can be a good way of working out what those places are made of. And that can tell us more about our solar system than meets the eye. For instance, in 2018, scientists were trying to figure out what Uranus's clouds were made of, in hopes of learning more about how it evolved. They knew Jupiter and Saturn have upper atmospheres full of ammonia, so they probably smell kind of like cleaning products. But scientists weren't sure if the same was true for Uranus. So the team used the Gemini North Telescope in Hawaii to try to decipher the planet's spectroscopic signature. That's like a unique barcode that you get if you separate light into all of its different wavelengths. Generally, certain lines will be missing, since every different kind of atom and molecule absorbs and emits specific wavelengths of light. So by looking at the missing ones, you can tell which atoms and molecules are present in a planet's atmosphere or a cloud of gas or anything else that light is shining through. Using this approach on Uranus, the researchers found that the tops of the clouds weren't so rich with ammonia compared to Jupiter and Saturn, but they were full of hydrogen sulfide, which does not smell like cleaning products. It smells like farts, because of course it does. But aside from confirming the very important fact that Uranus smells like farts, the discovery also gives us clues about how the planet evolved. The fact that Uranus has much less ammonia than Jupiter and Saturn, plus such high levels of hydrogen sulfide, suggests that it evolved farther from the sun, where ammonia was less common. And that also helps explain why Uranus is so small compared to Jupiter and Saturn. Out there, the swirling disk of materials that planets formed out of was less dense. So Uranus grew more slowly, and the disk ran out of gas before Uranus could get as big as its neighbors. So, in the case of Uranus, decoding its smell gave us a rare peek into what the solar system was like 5 billion years ago. But unfortunately, analyzing a planet's spectroscopic signature isn't always easy. The signals from different substances can overlap with each other, which makes it hard to tease them apart and figure out exactly which chemicals are involved in a given pattern. That's what happened to astronomers trying to figure out the composition of Saturn's moon, Titan. Astronomers have been interested in Titan ever since they discovered that it has a complex environment that could potentially support life. And one thing they've been trying to do is understand exactly what its atmosphere is made of. Beginning in the early 2000s, the Cassini probe gathered a lot of spectroscopic data, helping confirm that the atmosphere was mostly nitrogen and methane. But they couldn't decipher certain pieces of the spectroscopic signature. So they decided to try to physically recreate the atmosphere in the lab and use trial and error to figure out the missing pieces. To do that, they set up a chamber that mimicked conditions on Titan and filled it with gases they knew were in its atmosphere. Then they added a small amount of other ingredients until the combination in the chamber had the same spectrum as Titan's atmosphere. The missing ingredients ended up being a bunch of molecules from a group called the aromatics. Despite the name, not all aromatics actually smell like anything. But many of the ones that do have a scent are said to smell sweet, although one of those aromatics was benzene, which is found in crude oil and smells like gasoline. Titan as a whole probably doesn't actually smell much like those compounds, since the atmosphere is dominated by other gases. But still, the fact that it's full of complex molecules like aromatics tells us something about the chemistry on Titan, which can help us figure out if and how it could ever support life. In general, that's about as close as we can get to knowing what other worlds smell like. That said, now and then it is actually possible to smell something from space itself, like meteorites. Meteorites tend to look like plain old rocks, but some of them have pretty unusual scents. For instance, one clay-like meteor, dubbed the Cosmic Mud Ball, is reported to smell like Brussels sprouts, or maybe even vanilla. It's not an exact science. Most of the time, your sense of smell is not going to be the most useful clue when you could just bring the rock to a lab. But the smell does reflect its formation. The smells from the cosmic mud ball come from complex hydrocarbon molecules and amino acids. And by studying their composition, we can better understand the composition of the early solar system, especially since some of the molecules in those rocks are even thought to have formed before the sun. And yet they're the same molecules that life needs to exist, so they can help us trace the earliest stages of our origins. There's one small catch though. Even though these meteorites come from space, it's likely that Earth influences their scents quite a bit. Like the cosmic mudball's scent has probably been affected by Earth-based amino acids, not just the ones it brought with it from space. So until we can actually go there, there's always a little uncertainty when it comes to decoding the scents of the cosmos. But even so, it can give us a new way to explore uncharted territory. Thanks for watching this episode of SciShow Space. And if you liked this episode, you might like our episode about the cloud of booze in space, which, if you could smell it, would smell like rum. You can watch that one next.